Given a triangle, like the one pictured, we can use the sine rule to find the length of a missing side or a missing angle using the formula shown. Sometimes the sine rule can produce two solutions for a missing angle, one of them obtuse and one of them acute, so we need to make sure that we always get the acute angle. To do these questions, we need to draw a diagram and label everything we know. So we have a triangle PQR. And we know that side PQ is 12. Angle PQR, so that angle at Q, the middle letter, is 62. And the angle RPQ, so the angle at P, the middle letter, is 53. And the thing that we're asked to find is the length of PR. So let's call that X. You can change the formula so it's in terms of PQR, or we can put on little letters. So it's easier if we let the thing that we're trying to find be A. So the length A is opposite angle A, length B is opposite angle B, and length C is opposite angle C. We want to find the length A, so A over sine A. And we know that the other length is B, so is equal to B over sine B. We know the length little b, but we don't know the angle big B. We can find it, however, as the total angle in a triangle is 180. So 180 minus 53 minus 62 will give us angle B, which is 65. And now we can fill in our formula. So A over sine 62 is equal to 12 over sine 65. And we can rearrange this to find A. So A is equal to 12 sine 62 over sine 65, which we can use our calculator to find. So A is equal to 11.7 centimetres to 3 sig fig. So we can say that PR is equal to 11.7 centimetres to 3 sig fig. Again, we need to draw a picture and fill in all the information we can. We know that side PR is 9.3 centimetres. RQ is 8.2 centimetres. And angle QPR, so that angle at P, the middle letter, is 45 degrees. We're then asked to find the angle at PQR, so Q, the angle at the middle letter, is what we're trying to find. Again, we can label each side of our triangle, with A being the angle that we want to find, so big A, little a the length opposite, and then B and C are the other two sides and angles. We've got information about two sides, we've got an angle and we want another angle, so we use the sine rule for angles. So sine A divided by A. We know length B, so is equal to sine B divided by B. And we also do know angle B. So we can straight away substitute in the information we know, which gives us sine A divided by 9.3 is equal to sine 45 divided by 8.2. And we can rearrange this to get sine A by itself. So sine A is equal to 9.3 sine 45 divided by 8.2. So all we've done is times both sides by 9.3. We then need to do inverse sine. So A is equal to inverse sine, or sine minus 1 of 9.3 sine 45 divided by 8.2. And using our calculators, we get that angle A is equal to 53.3 degrees. So PQR is equal to 53.3 degrees to 3 significant fig. We can use the cosine rule to work out the missing side. If we know two sides, then the angle between them is given by this formula. But we can work out an angle if we know three sides, if we rearrange the formula to get cos A by itself. Again, we need to draw a diagram to help us in these questions. Now we can label everything we know. So side P, opposite angle P, is 5 centimetres. Side Q, opposite angle Q, is 12 centimetres. Angle R is 75 degrees. And we're asked to find the length of side R, so opposite angle R. We're asked to find R. Again, if you prefer to label it with A, B and C, A is the length we're trying to find, opposite angle A, and B and C are just the other two sides and angles. Okay. We know the angle between two sides, so we use the cosine rule in the form A squared equals B squared plus C squared minus 2BC cos A, as we're trying to find a length, and we can substitute in everything we know. So A squared is equal to 12 squared plus 5 squared minus 2 times 12 times 5 cos of our angle A, which is 75. We then need to substitute everything into our calculator, and we get A squared is equal to 137.9417. So to find A, we need to do the square root. And this gives us A is equal to 11.7. So we know that side R is equal to 11.7 centimetres to 3 significant figures. The first thing we need to do in this question again is to draw a picture. And then we can label everything we know. So we know side P, opposite angle P, is 11 centimetres. Side Q, opposite angle Q, is 15 centimetres. And side R is 19 centimetres. So we're being asked to find the angle at P. So again, we can label that as angle A. So always label the thing you're trying to find as A, and the other sides as B and C. We're now trying to find the angle, and we know three sides, so we need to use the cosine rule, but in the form of finding an angle. So we want cos A itself, which you can get by rearranging the cosine rule we've previously used, is equal to b squared plus c squared minus a squared divided by 2bc. And again, this is I'm filling what we know. We know that b is 15, so 15 squared. And we know that c is 19, so that's 19 squared. Take away a, which is 11, squared divided by 2 times b times c. And again, if we use our calculator, we can simplify that to give us cos A is equal to 31 over 38. And again, we then need to take the inverse, so A is equal to inverse cos, or cos minus 1 of 31 over 38. So A is equal to 35.3 degrees. So we can say that angle P equals 35.3 degrees to 3 sig fig. We know from GCSE that the area of a right angle triangle is half times base times height, but we also have an equation for the area of a non-right angled triangle. So given the triangle like before, the area is equal to half AB sine C. Just be careful that the sides you use are the sides either side of the angle given. So again, if we look at an example of this, we need a picture to start with. And then we can label everything we know. So side P, opposite angle P, is 8 centimetres. Side Q, opposite angle Q, is 12 centimetres. And side angle R is 75 degrees. We're asked to find the area, so we're going to use our area formula. But firstly, we'll label our triangle. So the two sides that we know, sides A and B, and the angle between them is angle C. So now we can use our area formula. So area is equal to a half AB sine C, which is equal to a half times 12 times 8 sine 75, which is equal to 46.4 centimetres squared to 3 sig fig. In this question, we've already been given the diagram, so we can start off by labelling on the information that we know. So we've got the port, and two ships travel away from the port. So ship A travels at a constant speed of 18 kilometres per hour. For 1 hour it travels 18 kilometres. and ship B travels at a constant speed of 25 kilometers per hour. So in 1 hour it travels 25 kilometers. And then we're asked to calculate the distance between A and B at 1400 hours, which is 1 hour after they left the port. So we're asked to calculate this distance here. We are told the bearings that each ship travels on. So the first ship, ship A, travels on a bearing of 70 degrees, which is the distance measured round from the north line. And ship B travels on a bearing of 152. So again, the distance travelled from the north line. So that total angle there is 152 degrees. But the angle that we're interested in is the angle inside our triangle. So this angle here. We can find that angle by finding the difference between the two bearings. So if we do 152, take away 70, we get 82 degrees. So that angle is 82 degrees. We've got an angle and the two sides either side of it, and we're asked to find a third side. So we need to use the cosine rule. So we can change our formula, or we can change the letters on our diagram, which is easier. So the side that we're trying to find, we label it as A. And the angle opposite, angle A. And the other two sides and angles, B and C. The cosine rule, when we're trying to find our length, is A squared is equal to B squared plus C squared minus 2BC cos A. So we can substitute in what we know. A squared we're trying to find. B we know is 25, so 25 squared plus C is 18. So 18 squared minus 2 times 25 times 18 cos of our angle A, which is 82 degrees. Using a calculator, this gives us A squared is equal to 823.744 2091. So A is the square root of 823.7442091, which gives us A is equal to 28.7 to 36 fig. So this tells us that the distance between A and B at 1400 hours is 28.7 kilometers to 3 sig fig. Now try textbook exercises 9A, 9B, 9C and 9D and do the following questions. So 1, 2 and 3 from 9A, B, C and D. Make sure you see any maths teacher if you're having problems with these questions before your homework is due in.